So the first routing protocol we're looking up for is RIP. It's called another name for RIP. It is not rest in peace. I think people always think that RIP means rest in peace. No, far away from that. RIP means that, or the full version or the full wording for RIP is routing information protocol. It was the first routing. I stand to be corrected, but I believe it was one of the first routing protocols that was created after they noticed that static routing was not helpful. Because with static routing, you have to manually go into the devices and configure them yourself. And so it brought about a lot of challenges. So they created RIP, which is Routing Information Protocol. Now it is open standard, which means that it is not for Cisco. It is not for any vendor. So if you're using Cisco, if you're using Juniper, using HP, if you're using Huawei, if you're using Aruba, if you're using Arista, it doesn't really matter. These are all vendors that can also implement RIP. So they also speak RIP. It means that RIP can be configured on them as well. But RIP version 1 is classful, meaning it only accepts the default subnet mask. So if you're using a network like 192.168.1.0, you don't even have to put in the subnet mask. It also means that by default, the subnet mask will be 255.255.0, which means it's a class C. And so when that's what it means, so it automatically will be using the class C subnet mask to send your messages. But like I mentioned earlier on, with RIP, we're looking at especially class with RIP version 1, the anytime the device wants to send an update about the networks that it knows about, it sends it to a broadcast address, which is to all 255s. Somebody will say this is the global subnet mask, but this is similar, but it's not that. This is a broadcast address which sends it to everybody within the scope. Now, with RIP, so let's say this is the devices you have. So let's say this is R1, this is R2, this is R3. Now, if we want to, and we want to go to maybe 20 network. Now with RIP, if we want to go to 20 network, we have two directions. The first one, we have to go from R1 to R2. And when we get to R2, it means we get to the 20 network. The second one, we have to go from R1 to R3, then to R2. What RIP is saying is that it has two networks. So this guy will say, hey, I know about this guy, how to get to 20. This guy on this interface will also say, hey, I know about this in 20 network, and this guy also send it here. So R1 will receive the information from two different directions. The first one is saying that in order for you to get to 20 network, you need to go to R2 straight ahead. The second one is saying that you need to go to R3 and then from R2 go to R2. Now, because your device understands RIP, it will have to decide which of the two routes will be the most appropriate one, or which of the two is the best route. And so how does it make that decision? It will base that decision on what we call hop count. So we say, okay, I know that if I want to go to 20 network and if I use R2, it's only one hop away, meaning just one jump away. But if I decide to go to 20 network, if I decide to go via R3, it means I need one hop, two hops. So with RIP, it will make a decision based on this assumption. You said, okay, if I use the left one, if I use the top one as one hop, if I use this one is two hops. So between the two, RIP will say that I'll go with the top one because it gives me the shortest distance. But that's the challenge. If it's going with this one as one hop, maybe this one is a slow link. Maybe this is 128 kilobits per second. And this is 1000 megabits per second. Ideally, this will go there faster, but because RIP only thinks about the number of jumps rather than the speed, RIP will make a decision based on the jumps, which is why we say that RIP is a distance vector protocol. It only, in order to make a decision as to which one will be the best direction, it only considers the number of jumps, which is the metric. That metric is called hop count. So metric means how do you make a decision? So the metric for RIP is hop count. And so it makes its decision based on the number of hops. Now, another thing about RIP is that RIP does what we call load balancing. But it does the kind of load balancing RIP does is what we call the equal path load balancing. So what it means is that there may be cases where you have more than one path to a destination, but all of them present to you the same distance in terms of RIP. So let's say I have these two devices. So let's say I have this network, this place, and this place. And if I want to go here, let's say this is R1, this is R2, R3, R4, and R5. Now, if I want to go to 20 network, if I want to go to 20 network from R1 via R2, I'll go to R1. I'll move from R1 to R2 to R5. And this is 2 jumps. I'll say 2 hops. I can also go from R1 via R3, which will present R1 to R3 and R3 to R5. And that's also 2 hops because 1, 2. Now, I can also go from R1 via R4, which is R1 to R4 and R4 maybe to R5. This is also 2 hops. Now, when we say equal load balancing, this is what I mean. Now, I know that I can go to my destination using 3 different routes. This route, another route, and then another route. But the funny thing is that none of them is better than the other. They all presenting the same metric, so 2 hops. And so RIP is saying that if the best routes is not just one route and we have multiple of them, you can use a maximum of 4 best routes. So it means that we can send some of our information through this link, some of the information through this link, and send some of the information through this link because they are all having the same metric or distance. The maximum we can do is 4 if they all have the same equal paths. We can only use 4 equal paths. That's what RIP does. But also, that's what the load balancing means. Load balancing means that you can send information via different directions if they all present themselves the same distance. But there's also what we call the maximum hop count, which is something we're going to look at now.